We want to talk about porosity first. And basically, porosity is just a way of describing the area that the oil can be in, oil, water, liquid. If this solid is pushing directly against that one and this one directly against this one, in a sphere, it's going to leave this little triangle. And in a perfect world, okay, I didn't get that one touching, but you get the point. You end up with this little area here. That's where your oil liquids hide. That is the volume you're going after. So what you're describing porosity, that volume of area. When we talk about permeability, we're talking about the ability for oil to flow through the rock. How well connected are these little pipelines to where the fluid can get through it? And there's a lot of things that can affect that. For example, if my oil flow was coming from this direction and this was my well bore with holes stuck in it, thank you. You could see how this big sand particle or this granite or whatever it is, even though this reads very consistent in porosity, the ability for oil to flow across this particular channel would be hampered, therefore your permeability may not be so great. What I want to do is just to give you an example. You can see that that sand is filled up all the way to the top of the bag. We're going to go over here to the sink and we're going to see this glass is filled up right to those arches there, right to the top of the arches. So we're going to walk over here and kind of see the amount of oil and we're just going to try to fill it up to the top, give you an idea. But that's quite a bit of liquid in an area that's already full of a solid. So people ask, some people actually think that there's a lake of oil down there and it's just a big lake and it's going to collapse and all of that, but the sand actually sits on top of itself and the liquid sits in the pore space, and the pore space is referencing these little triangles. Can we see that? Mm-hmm. Okay. And the pore space, when you're talking about porosity and permeability, okay, the porosity is referring to the pore space. How large are these little triangles? How open they are, how much oil they'll hold. And as you can see, they'll hold a lot even with the solid in there already. And it filled up quite easily. As you can see in the box there, you've got large sand particles, small sand particles. You've got broken, reworked granite. Okay, so now you've got water and beach sand that's been laying around for a couple of million years, along with newer, broke down granite, which is much finer. Okay. And basically I'm just trying to give you an example of what we're dealing with and the different problems that you deal with in California and why people kind of shake their head and look at you funny when you're saying you're producing California sands. This gets worked into the mix as well. Because of the upper crust moving, all right, so now let's put this in our little bag. We're going to take this and just we're going to control and put these in occasionally, otherwise they're just all going to end up at the bottom. Okay, let me do this. All right, if you remember the nice clean little sand that we took a picture of before, this is California sand. And that looks terrible. But that's what we deal with, okay? It's got the reworked shale. It's got void spaces in it. Now, if you've got 1,000,000 years to fill in the voids instead of 2 seconds, you don't have as many of them. But if you looked under a microscope at core samples, you will find that when you core down through the earth, you see these bubbles in those cores. And that's exactly how they get formed. There's no place for the pressure to go. You get a gas bubble trapped in there. There's no place for it to dissipate because it's sealed, and the earth just keeps shoving down on it. So you end up with these gas trap seals here, okay? So here we are with our California mixed up mess, full of sand, shale, all of the various different blocking things that affects not only porosity because it fills in those gaps, but permeability. And so you see how it acts a little different when you, with the color. Now remember before when we were putting this in there, the whole thing was very even. The color saturated very evenly. And you're not seeing that at all now. So permeability and porosity in California can be a little bit challenging. But that's again why we rely on our gas pressure to drive it to us, okay? Once the gas is dissipated, you have pushed the fines out of the pore space. You have pushed open forcibly, opposite of a frac, okay, where they mechanically impose their will on the formation. We're allowing the formation to clean up the pore throats of the permeability and porosity of the formation. Now, once that gas is gone, all right, everybody says, well, what are you going to do when the gas is gone? It won't produce no more. Well, that's not the case so much, because as that gas forces from the top through all that area, those fines separate out and you find them later on, okay? Now that you've gone through this process a couple of times, look how easily that goes through there. So what you're actually doing is opening up your zone using the natural gas pressure. And then once you get ready to run a pump, you've cleaned it up to the point where the oil will flow through it.
Maybe less volume.
Oh yeah, it won't be the volume because you're looking at natural gravity flow. But you want to utilize that gas pressure to clean that formation up so that you have permeability and porosity, so that you have pore throats, and so that you have a channel for that oil to come through, and you let that natural pressure of the gas develop that for you, hopefully. And then by the time you get ready to run the pump, you end up with a lot cleaner. As you can see now, we've washed a lot of those fines. Look in the bottom of my little grid here where the fines have washed down to the bottom, okay? And you've got a lot better oil mobility. And history has proven that this is true because years ago, back in the 40s, when they would develop these wells and they would flow for 3 or 4 months and then drop off, lo and behold, amazingly, they could run a pump in the hole and it would still make 250 to 300 barrels a day under its own gravity flow, okay? There's no way that that formation will allow you to do that on its own. You have to allow the gas to clean up the zone and get rid of the fines so that the oil has a way to flow. And so, in our own awkward way, I'm hoping this helps to explain the differences and why when you go to Texas you see one kind of development. When you come to California you see a totally different style of development. And basically a good oil man will read his rocks, read his dirt, and do what's necessary to take advantage of that particular formation. Hope that helps.
Valid Energy, powering our future today. We'll catch you later.